Hello, good morning, students. I hope all you are fine. And how was your exams? I think it was easy questions, and I hope all you answered very well. So today we are going to start our third chapter, current electricity. So in the first class, I discussed about two type of electricity. How many of you remember that one? Yeah. Okay. So one is static electricity, and other one is tell me. Current electricity. Okay. So there are two types of electricity, static and current. Static electricity deals with the charges at rest, and current electricity is the branch deals with the charges in motion. Okay. So when we discuss about a moving charge, it comes under current electricity. Okay. So when we talk about the current electricity, we have to define some terms related to that one. So in class 10, we learned about the definition of current. So electric current is defined as the rate of flow of charge. But actually it is not electric current. It is intensity of electric current. So you have to say like that. The symbol of electric current, we use I. From where we got this I? In current there is no I. So this I stands for intensity. So intensity of electric current, that is the correct word. So how can we define intensity of electric current? Intensity of electric current is defined as, you can see here, intensity of electric current is defined as the rate of flow of charge. Rate of flow of charge. That means how much charge pass through a conductor. Suppose this is a conductor. Let's take this as a conductor. And if the charge is passing from this point to this point, and if a charge, only one charge passes from this point to this point in 1 second, then it is called, then the current is 1 ampere. Okay. So rate of flow of charge, so we can write it as I is equal to Q by T, where Q is the charge. There also Q stands for charge. From where we got this Q? It is quantity of charge. Q stands for quantity and I stands for intensity of current. Okay. So charge by time. So from here we can define the unit of the electric current. So what is unit of electric current? It is ampere. Okay. So how can we define ampere? We can define ampere like 1 ampere is equal to 1 coulomb by 1 second. How can we say that? Because we know that I is equal to Q by T. The unit of I is A, ampere, and the unit of charge is coulomb and unit of time is second. So we are substituting this value. And if you want to get 1 ampere, then we have to make the other values as 1. That means 1 coulomb and 1 second. So we can define 1 ampere as if 1 coulomb of charge is passing through a conductor for 1 second, then the intensity of current is 1 ampere. That is the definition of 1 ampere. And when electricity is passed through a conductor or passed through material, depending on the conductivity, we mainly divide it into 3. First one is conductors. Mostly they are metals. Okay. So conductors allow electricity to pass through it. Okay. There's very less hindrance or the opposition for passing of charge through it. Now we are coming to the next one, is semiconductor. It allows charges to pass, but the resistance is high and it is not able to pass the charge in all conditions. Okay. As compared to conductors, the conductivity is very less. And third one is insulators. They never allow charge to pass through it. So there is this, it can conduct a electricity. So plastic, glass, etc. are the examples of insulators. That is why we are using plastic for wrapping these electric circuits. So when we talk about current, there are two types of current. One is steady current and other is variable current. Steady current means there is no change, there is no fluctuation. For example, the current from the battery. So when we connect a battery to a circuit, the current is steady flow. There is no change. And the variable current is called alternating current. So there are two types of current. One is direct current and other one is alternating current. Direct current is we got from the battery, and alternating current is the current we are getting from the electric supply in our home. So it is changing. If you closely observe a bulb, that is incandescent lamp in your house, you can see it is blinking, but it is blinking at a rate of 50 times in a second. And due to the persistence of vision of our eyes, we are not able to identify that. But if you closely observe, we can see the blinking. And sometimes in this video also you can see the light is blinking. But when we look at the light, we can see. But in this video, you can see sometimes the light is blinking side because of the fluctuating electricity. So there are two currents. One is direct current and other one is alternating current. And when you talk about the current, what is the meaning of current? The meaning of current is a flow. And when we talk about any current, we have to think about the direction. In case of electric current, there also a direction of flow is there. So the electrons are flowing from one point to another. So suppose it's a conductor, and electrons are flowing. Electrons are charge carriers. They are flowing from this point to this point. That means electrons are flowing in this direction, and from this to this, from left to right. And we take the direction of current is from right to left, because the direction of current we usually denote from is the direction of positive charge. So electrons are moving from here to here. That means the current is the opposite. So the direction of flow of electron is opposite to the direction of the conventional current.
Cell has one positive and one negative terminal. The difference of potential between these two terminals is measured in volt, and this difference is due to an excess of electrons at the negative terminal compared to the positive terminal. If we connect a wire across these two terminals, the potential difference causes an electric current to flow in the circuit. This current is nothing but a flow of electrons that come out from negative terminal, move along the wire, and enter the cell by the positive terminal. However, before invention of this electron theory of current flow, the scientists of the 17th century arbitrarily decided that the electric current flows from positive potential to negative potential. This is so-called conventional flow of current. Till today.
Before we go into the main topic, we have to discuss two more important terms. One is the current density. So current density is, we can define it as the current per unit area. We can define it simply, we can define it as current per unit area. Okay. So I will read the definition for you. The current density at a point in a conductor is defined as the amount of current flowing through unit area of the conductor around that point, provided the area is held in a direction perpendicular to the current direction. Okay. So suppose this is a conductor, and let us take a small area, this one, this area. So if a current is passing through this one, let us consider this as a unit area. Let us take this as area as 1. It is not 1, but let us consider it as a 1 square centimeter, square meter or something. Okay, unit area. So the current density is the amount of charge flowing through this point. Okay, that's the current density, not this point, through this area. Okay, so we denote the current density by the letter J, small letter J. Okay, so we can define J is equal to I by A. J is equal to I by A. So what is I? I already told you I is the intensity of electric current and A is the area of the conductor, area of the cross section. So we can define J is equal to I by A. So from here we can find the unit for A. Unit of I we already discussed, that is ampere, and area, unit of area, we know that it is meter squared. So we can write current unit of current density as ampere by meter square, ampere per meter square. We can write it as ampere per meter square, or we can write a m raised to minus 2. Now let's discuss about the potential. So we know, we already learned what about the potential in class 10. So electric potential is the work done to take a unit charge from one point to another point. So in some textbook they are defined as infinity to a point. That is the electric potential that we learn in previous classes. But today we are going to discuss about electromotive force. Electromotive force. So electromotive force and potential difference, there is a small difference. Now I have a cell with me, and it's here it is denoted as 1.5 volt. Okay, you can see 1.5 volt here. I think it is not able to see. Okay, so it is a 1.5 volt. Okay, so what is this 1.5 volt? Is it potential difference or EMF, electromotive force? So when this cell is not connected to a circuit, there is a potential between these two ends. That is called electromotive force or EMF. EMF means the potential of a source. Potential of a source when there is no connection. When there is no connection. But if I connected this source with a wire, now there is potential difference. Okay, it is a potential difference. Once we connected this cell, it is a potential difference. Otherwise, it is called a electromotive force. So, electromotive force, the definition is electromotive force. I will read the definition of electromotive force for you. Electromotive force is defined as the amount of work done in sending unit electric charge once around a closed circuit. Once around a closed circuit. So, it is the work done. Some work is needed to push a charge from here to the circuit. So because of this force, this charge is flowing from the circuit. And now we are coming to the first law in this chapter. It is Ohm's law. The law is put forward by the famous scientist George Simon Ohm. So he do some experiments and he found a relation between the potential difference and the current. I think you guys learned something about this law in class 10. Okay, so suppose this is a conductor and there is some potential difference here. So here it is a potential difference 10 and here it is 5. Okay. So when there is a potential difference between the ends, the charge start moving. That means there is a current. Simply we can take the example of a water connection. Suppose this is a pipe and there is a water tank here. Let us take this as a water tank. So water tank is there. And this pipe, now I am connecting pipe horizontally. How about the flow of water? The water will flow. Now I am changing the direction. I am just sliding the pipe. What happened? What happened to the flow of water? Yeah, it will increase. Okay, it will increase. So the flow of current will, when the sliding or the obligation is increasing, the flow of water will increase. Why? Because in class 9 and 11 we learned about potential energy. Potential energy depends on the height. So when the height is more, the potential energy is more, and height is less, the potential energy is less. So here the potential energy is more and here it is less. So water flows from a point where the potential energy is high and to a point where the potential energy is less. Similarly, in the case of electricity also, the charge flow from higher potential to the lower potential. And when the charge is flowing, it obeys a law called Ohm's law. And Ohm's law states that at constant temperature, or in some books they are saying that at the same physical state. Same physical state means temperature, pressure and volume. These are the physical states that we are considering. And for a conductor, there's no need of pressure and volume. It is not going to change. Okay, so we only consider temperature. So that is why we are saying at constant temperature. If you say it is constant or say physical state, that is also correct. Okay, that's the more correct word. But here the only affecting thing is temperature. That is why we are saying like that. Also states that at constant temperature, the current flowing through a conductor is directly proportional to the potential difference between its ends. Please read it. What is Ohm's law? Ohm's law states that at constant temperature, the current flowing through a conductor is directly proportional to the potential difference between its ends. That is V proportional to I. So if we want to remove this proportionality sign, we have to insert a constant and that constant is called R. So V is equal to IR. V is equal to IR, where R is the proportionality constant and it is called the resistance of the conductor. Please note resistance of the conductor. Please remember that conductor. We have to discuss something in the coming session. Okay. So resistance is the for a conductor. That means if I take this conductor, for example, this is a copper. Let us take the copper. And if I take this part, there is a resistance here. And if I take this part, there is a resistance here. And if we take the same material with some increased size, then there is a resistance. So resistance of the particular piece, resistance is for the a particular part or particular piece of that one. Okay, though so the unit of resistance is ohm. Okay, and in the circuits we need to connect different resistors to adjust flow of current in the circuit. So we use resistors, and the symbol of resistors are this. You can see here. Okay, resistors. Okay, so when a circuit is established and the current starts flowing, there is a resistance. Resistance is a part. We can't have a resistance. So what is resistance? It is the opposition or the hindrance to the flow of electrons. Okay. So when electrons are flowing, there is a resistance from the side. So what are the factors affecting the resistance of a conductor? That's what we are going to discuss. First one is length. So if the length of the conductor increase, the resistance also increase. Similarly, in a traffic, the length of the block is increased, we have to face a difficulty to reach there. But the length of the traffic block is less, we can pass it very clearly. Like that, if the length is increased, the resistance also increased. Next one is area of cross section. Okay. So let us consider a narrow road and a wide road. So to which road you can move fast? Wide road. Similarly, that means the area is increased. Like that, if the area of the cross section is increasing, that means from here it is increased like this, then the resistance will reduce. That means resistance is inversely proportional to the resistance of the area of the cross section of the conductor. Next thing, nature of the material. Nature of the material means the resistance depend on different material. For silver, it is the best one, and after silver, it comes copper, then aluminum. This is the order. So for a particular material, there is resistivity. So resistance, and that is called resistivity, specific resistance or resistivity. We call it, it's called specific resistance or resistivity of a material. Next one is temperature, and these are the four factors affecting the resistance of a conductor. Mathematically, we can write it as R proportional to L by R proportional to L by A. So in where L is the length of the conductor and A is the area of cross section. And here also we need to remove this proportionality sign. So what can we do? We can, what can we do? We have to put a constant, and this constant is called rho, where is it is called the resistivity. And resistivity is depend on the material. Okay, and resistance is for a conductor and resistivity is for the material. Are you able to understand? Okay, and what is the unit of resistivity? We're substituting the values. R is equal to rho L by A, or from here we can write rho is equal to R A by L. So R A by L, A and L get cancelled because meter square and meter get cancelled, and only meter is there. So the unit is ohm meter. The unit of resistivity is ohm meter.